Tonight, we are walking into one of the strangest blank spots hidden deep in prehistory, a stretch of time so vast that almost everything inside it has gone silent. Modern humans have existed for 300,000 years, yet recorded history covers only the last 5,000. The other 99% are missing. Across the next quiet hour, we follow that silence into the places it still half remembers. Picture history the way most of us learned it. Today there are records of almost everything. 500 years ago, written accounts, painted portraits, ledgers, and parish books. 2,000 years ago, Rome was documented through laws, coins, road maps, public inscriptions, and entire libraries of letters that still survive in original manuscripts. 5,000 years ago, the first cities rose in Mesopotamia and along the Nile, and the earliest writing systems began to scratch their way into clay and stone. That is the part of the past we can actually read. Behind it, the picture begins to fade. No books, no carved kings or named rulers, just the things people happen to drop and the things weather happened to spare. Hand axes in dry riverbeds, hearths sealed under cave floors, the occasional skull pressed into sediment. The further back the timeline runs, the thinner those traces become, until eventually the record stops looking like a record and starts looking more like scattered notes torn from a book that no longer exists. That is where the question begins. Modern humans, the same species sitting in chairs right now with the same biological hardware that lets you understand these words, have been on this planet for roughly 300,000 years. The fossil evidence is solid on that number. Skulls from Jebel Irhoud in Morocco, dated to around 315,000 years ago, already look essentially like ours. Yet for almost all of those years, we cannot see what the people carrying that biology actually did. But the math behind that biology refuses to add up. Modern humans, with our skulls and our brains, have been around for 300,000 years. Civilization, the part with cities and writing, has been around for about 5,000. Subtract one number from the other, and the answer is 295,000 years where the biological hardware existed, but the recorded behavior did not. That is not a small gap. That is roughly 99% of modern human existence sitting in a blank space on the timeline. 12,000 generations of fully modern people, give or take, who lived complete lives between birth and death and left almost nothing behind that we can read with any confidence. The neat curve from cave to city, the one school books like to draw, is mostly an empty page held together by a thin line of dates. But the gap does not get easier as you look closer. Every dig that uncovers a hint, a worked bone, a hearth, a possible burial, opens 100 questions about what was happening in the spaces between those finds. A single site in southern Africa gives us a snapshot of one small band in one valley for a few centuries. The rest of the continent, at the same date, is silent. Multiply that silence across the whole planet, across 300,000 years, and the missing record stops being a gap. It becomes the main feature. Therefore, the math is not a small mystery. It is not the kind of gap that gets filled by one more dig in one more cave somewhere. We are looking at a stretch of time so wide that almost every assumption about who we are has to bend around it. 300,000 years of anatomically modern people, 5,000 years of records. The space between those two numbers contains roughly 12,000 human generations whose names, languages, songs, fears, and discoveries have all gone quiet at the same time. Therefore, the picture school taught you the neat curve from cave to city was always a story drawn with most of the page missing. Most of who we have been is no longer reachable. The silence is not laziness on the part of researchers. It is a real, physical absence of evidence stretching across continents, climates, ice sheets, ocean shelves, river valleys, and entire ecosystems that no longer exist in the form they did when humans were living in them. The bones that survived are scraps. The tools are fragmentary. Almost none of the places people actually lived have ever been excavated, because most of them no longer exist. So the question is no longer whether the gap exists. The gap is measurable, datable, and globally distributed. The question that matters now is what those 295,000 years actually contained, and why so little of all that human living, dying, building, and learning ever managed to reach the present in any form we can still study. Before we go further into that human silence, there is something the planet itself does that puts the whole question in a different light. If you walk to the right spot on the right continent, you can touch a place where the rock skips 1 billion years. No layer, no transition, just a thin line between two worlds. And what happened to that rock across a stretch of time longer than every animal species combined has been alive? Turns out to be a useful map for understanding why the human past went missing too. Walk into any canyon or cliff face, and the planet looks like an honest historian. The rock is layered. Each band sits above the band that came before it. Mud became shale, sand became sandstone, calcium settled out of ancient seas and became limestone, and volcanic ash drifted down as its own thin grey line. Geologists call this principle superposition. The lower layer is older, the higher layer is younger, and the world wrote itself down in order. That is the picture you learn in school. The Earth has kept a diary, page by page, since the planet was young. A geologist reads it the way a librarian reads a shelf, slowly moving from spine to spine across hundreds of millions of years. Stand at the bottom of the Grand Canyon, and the diary is almost 2 billion years thick. The rocks under your boots are 1.7 billion years old, and the rocks at the rim, more than a kilometer above your head, are only 270 million years old. So imagine being down there. The Colorado River runs beside you. Above, the cliffs rise in red and orange and dusty white, each band a different chapter from a different era. Somewhere in that wall, near the very bottom, sits the boundary the next part of the story rests on, a single thin line in the rock that should not be there if the diary really was kept page by page, the way school children are taught it was. But the diary is not complete. Walk down to Blacktail Canyon at the bottom of the Grand Canyon, and you will find a place where 2 pages of that diary sit pressed together with 1 billion years missing between them. The rock just below the line is the Vishnu schist. Dark and twisted, it formed in the heart of a mountain range that no longer exists anywhere on the planet, around 1.7 billion years ago. The rock just above is the Tapiat sandstone, flat and horizontal, roughly 520 million years old. Between them, in the space of a single line you can touch with one finger, there should be over 1 billion years of sediment, fossils, ash layers, and seabed deposits. None of it is there. The diary skips 1/4 of its own length, but that absence is not unique to one canyon in Arizona. The same boundary with the same gap shows up on every continent that has been studied carefully. Geologists call it the Great unconformity. In some regions, the missing time runs to nearly 1.5 billion years. In others, it is closer to 700 million. Whatever happened to those rocks happened almost everywhere on the planet at roughly the same time, and it removed so much of Earth's record that the question stops being about how the diary was kept. It becomes about how a planet manages to lose a quarter of its own history without anyone noticing for most of human science. Therefore, the line in the rock at Blacktail Canyon is not poetry, it is data. When you touch the boundary between the Vishnu schist and the sandstone above, your finger crosses more time than has passed since the first multicellular life appeared on this planet. Geologists worked out how that became possible. Around 1.1 billion years ago, the continents pressed together into the supercontinent Rodinia, and the heat trapped beneath that single landmass lifted the crust by kilometers. The shallow seas drained off the edges, and sedimentation, the process that writes Earth's diary, slowed almost to nothing. Therefore, the record stopped getting written. Then, around 717 million years ago, the planet tipped into the deep glaciation known as Snowball Earth, and ice sheets ground across continental rock like industrial bulldozers, scraping away the older layers that had survived the lift. So, the missing billion years did not vanish through some mysterious process. A supercontinent rose, drained its own shallow seas. Then, Ice Age glaciers finished what the uplift had started by scraping the exposed rock down to its old, twisted basement. This matters because it changes the question: if the planet itself can lose a quarter of its own history through ordinary physics, then expecting human prehistory to be intact across 300,000 years of ice ages, sea rises, eruptions, and erosion is a strange position to hold. The expectation of completeness is what needs explaining. The absence of it does not. So if the planet itself can lose a quarter of its own diary, the question of where the human pages went stops feeling impossible. It starts feeling almost ordinary. Most of those missing pages were not buried in caves. They were written along shorelines that no longer exist above water. To understand why so much of our story is unreadable, we have to walk down to the place those people actually lived and notice what is now sitting on top of it. For most of those 300,000 years, the people we call modern humans did not live in caves or on hilltops the way school books like to picture them. They lived where the food was. They lived on coasts. The shoreline of an Ice Age world is one of the most generous environments a hunter-gatherer could find. Tides come twice a day and leave food on the flats. Rivers meet the sea and deposit fresh sediment that grows reeds, roots, and freshwater plants in dense seasonal beds. Migrating birds land in the marshes by the million. Seals come ashore to breed in predictable cycles, and driftwood arrives free of charge. Fresh water sits in springs and creek mouths within walking distance of the salt. So, a family camped where a river met an ocean had access to more calories per square kilometer than any farmer would manage for the next 200,000 years. So, picture an ordinary day. Children move along the wet sand at low tide, prizing shellfish off rocks and dropping them into a woven basket. Older people work near a hearth a little further up, smoking fish on green wood and scraping a hide stretched across a frame of driftwood. A small group walks out across the flats with weighted nets, working in water no deeper than their knees. Somewhere, a dog barks at gulls. The wind moves the smoke sideways across the camp, and no one in that camp imagines that anything they leave behind will ever be hard to find. But the world that Camp was sitting on did not stay where it was. Around 12,000 years ago, the great ice sheets of the last ice age began collapsing, and as they melted, they returned an extraordinary amount of water to the oceans. Sea levels rose by roughly 120 meters between then and the present day. That is a vertical rise about as tall as a 30-story building. Every coast humans had lived on for the last 100,000 years went underwater. Doggerland, the grassland that connected Britain to mainland Europe, was overrun by the North Sea in stages between 10,000 and 6,000 years ago. The land bridge of Beringia, which had linked Siberia to Alaska as a habitable corridor, drowned beneath the Bering Strait. Sunderland, the broad plain that joined Indonesia, Malaysia, and Borneo into a single landmass twice the size of India, broke apart into the islands we see today. Everywhere humans had clustered for food, the ocean came in and quietly took the land back. But the loss was not just geographic, it was archaeological. The most productive parts of the human landscape, the river mouths and tidal flats and shellfish beds, are exactly the places where any traces of human life would have accumulated thickest. Camps returned to good fishing spots for thousands of years. Bones, hearths, tools, ornaments, and burial sites pile up wherever people stayed long. All of those places now sit under meters of seawater and meters of marine sediment, well outside the working range of nearly every archaeological project ever funded. Therefore, the simplest answer to why we cannot find most of prehistory is also the most unsettling. We have been looking in the wrong half of the planet. Almost every coastline humans actually lived on for the last 100,000 years now sits underwater. Sea levels at the peak of the last ice age were roughly 120 meters lower than today. That is not a small adjustment. Whole continents had additional shelves of dry land extending hundreds of kilometers beyond their present shores. The North Sea was a grassland called Doggerland, walked by hunters chasing reindeer. Siberia connected to Alaska through a habitable corridor wider than most modern countries, and Indonesia, Malaysia, and Borneo formed a single landmass called Sundaland that was roughly twice the size of India. Therefore, the places with the gentlest weather, the easiest fishing, and the most reliable freshwater were exactly the places the ocean later drowned. So, when archaeologists work on hilltops and inland caves, they are studying the few sites that happen to be above the rising water. The camps where people actually clustered around oysters, river estuaries, and freshwater springs are still down there, sealed under silt and broken apart by currents that have been working on them for 10,000 years. Therefore, the inland bias of the record is not because prehistoric humans preferred caves. It is because cave sediments hold their shape and seabed sediments do not. The most important pages of the human story are still underwater, and most of them will never be read. The drowning of every coastline explains where most of the evidence went. But the evidence that did stay above water has its own problem. What survives on dry land is a tiny, biased sliver of what humans actually used. The picture that builds in museum cases looks complete, the way a sentence looks complete when it has all of its hard letters and none of its soft ones. The actual world those people lived in was almost entirely made of things that do not survive a single century in normal soil. Picture the inside of an archaeological dig at a well-preserved site. Trowels scrape at sediment 1 millimeter at a time. Mesh screens sift the loose dirt for anything bigger than a grain of rice. Notebooks filled with sketches and grid references. Buckets of fragments wait in the shade for sorting. What fills those buckets week after week in almost every cave and rock shelter in the world is stone. There is a reason for that. Stone is almost indestructible on human timescales. A flake of obsidian struck by a careful hand 400,000 years ago will still be sharp enough to cut paper today. A hand axe shaped 500,000 years ago will hold its shape through fire, frost, river transport, and burial under 100 meters of sediment, then arrive at the surface looking almost the way it left its maker's hand. So when archaeologists describe the deep past in terms of stone industries, in terms of Acheulean tools, Mousterian flakes, and Aurignacian blades, they are not romanticizing. They are describing what they can actually hold. The picture this builds in the public mind is straightforward. Early humans flaked stone. They flaked smaller, more refined stones over time. The story of prehistory becomes a story of slowly improving sharpness, illustrated in textbooks, with photographs of perfectly preserved hand axes, neatly arranged like museum exhibits, each one labeled with a date that stretches across hundreds of thousands of years. The picture is calm. It is easy to follow. It is also misleading. But everything not made of stone is gone. Wooden digging sticks rot inside a generation. Hide clothing dissolves within a century or two in any normal soil. Cordage, woven baskets, nets, sinew, and the fitted leather seams that held a person's daily life together vanish so quickly that they are almost never found outside of bone-dry caves or waterlogged peat bogs. The list of what does not survive is much longer than the list of what does. So picture the actual world a hunter-gatherer lived in. Then imagine it stripped down to only the parts that would still be lying around 500 centuries later. The clothes are gone, the bedding is gone, the shelter frames are gone, bags, ropes, traps, and wooden bowls vanish in the same century. Drums and flutes, carved from bone or reed, mostly disappear. Body paint, dye, smoked fish, boiled root, the carefully balanced soup of a single evening meal, all of it gone. What survives is the sharp end of a tool that may have been the least interesting thing in the camp. But the stone itself can also mislead. A net does the work of many spears, and a needle does the work of many knives, but neither leaves a chipping pattern. Whole technological systems built around fibers, hides, and woven plant material would leave almost no trace at all, even if they had reshaped a band's entire economy. The picture preservation offered is not just incomplete, it is the wrong picture of the wrong life. Therefore, the image we carry of prehistoric people, hunched over stone, chipping flint, eating raw meat, is almost certainly wrong. It is the image preservation gave us, not the image they would have recognized. The people themselves lived inside a world made of materials that no longer exist anywhere on the planet. A wooden digging stick can do more in a day than a stone axe can. Cordage nets catch more fish than any spear ever did. Baskets quietly restructured how food was carried, stored, and shared in ways that changed entire societies long before farming existed. The bone needles found at Denisova Cave, dated to around 50,000 years ago, mean fitted clothing existed long before the last ice age peaked. Therefore, the technology people actually relied on was overwhelmingly soft, woven, sewn, or carved from things that rot within a few hundred years in any normal climate. So when an archaeologist digs up a layer of flint blades and almost nothing else, what survives is the sharp, hard fraction of a much larger system. The cords that held the blade to its handle have rotted away. along with the hide that wrapped whatever the blade was used to cut, the wooden shaft it was hafted to, the woven bag it was carried in, and the dyed fiber that may have decorated all of it. Therefore, preservation bias does not just hide some of prehistory, it hides the actively human part of it. What remains is the part that resembles geology more than culture, which is exactly why a quick glance at a museum case can mislead anyone, including the experts who built the case. So, even when archaeologists find a site that survived, what they find is the wrong half of the life that was lived there. But there is another problem sitting underneath the preservation question. The people themselves may not have stayed in any one place long enough to leave the kind of record we are looking for, because at certain points in their history, there were almost no people left to leave a record at all. Long before the rising seas, our species came close to ending entirely. Population biology gives us a strange picture of early humans. We were never numerous. For most of those 300,000 years, the entire global population of modern humans probably sat between a few tens of thousands and a few 100,000 at any one time, scattered across an entire continent or two. The reason is straightforward enough. Hunter-gatherer life supports a certain density and not much more. A family band of 20 or 30 people needs a hunting range of maybe 100 square kilometers of decent country to feed itself across the year, and considerably more than that in tougher landscapes. Stack enough bands across enough land, and you still only get a thin population spread out so widely that two bands could pass within a day's walk of each other and never know it. People moved through the world the way deer move through a forest, in small groups with long, quiet distances between them. So most of the time, the human species ticked along quietly, births and deaths roughly balanced, while group sizes stayed inside what the land could support. A child born in a band of 30 would meet maybe a few hundred other people in a lifetime, almost all of them already related to her by blood, marriage, or trade contact with the next band over. The picture geneticists pieced together from mitochondrial DNA and Y chromosome data is one of long, slow, mostly uneventful demographic continuity, stretching back deep into the prehistoric record without dramatic interruption most of the time. But the steady picture conceals something brutal. When geneticists look at modern human DNA, they find the unmistakable signature of a population that has been crushed almost to nothing more than once across the deep past. Around 74,000 years ago, the Toba supereruption in Sumatra blew approximately 2,800 cubic kilometers of rock into the sky, making it the largest volcanic event of the last 2 million years. The ash dimmed the sun across much of the planet for years. Temperatures dropped and forests thinned. Some genetic models, looking at the bottleneck visible in mitochondrial DNA, estimate that the global breeding population of humans may have fallen to as few as 10,000 individuals worldwide. That is roughly the population of a small American suburb, scattered across an entire planet, holding the entire future of the species in their hands. But Toba was not the only crash. A controversial 2023 paper in the journal Science argued that an earlier bottleneck around 900,000 years ago may have reduced our pre-human ancestors to barely 1,000, breeding individuals for over 100,000 years. Other compressions appear in Y chromosome data and in the strange flatness of genetic diversity outside Africa. The pattern keeps repeating the way a recurring fracture line shows up in an old bone. Every time it happened, the species came within a single bad century of ending entirely. Most species that get pinched that narrow simply go extinct, finished off by the next disaster or by accumulated inbreeding. Therefore, the numbers behind those bottlenecks are not abstract. They are sitting inside the genome of every person watching this. Modern human DNA carries the unmistakable signature of having been squeezed down to a tiny breeding population, not once, but several times across our history. Around 74,000 years ago, the Toba supereruption in Sumatra blew roughly 2,800 cubic kilometers of rock into the atmosphere, making it the largest known eruption of the last 2 million years. Estimates suggest global temperatures fell by several degrees for years afterwards, and some genetic models place the surviving breeding population of humans at perhaps 10,000 individuals worldwide. Therefore, the entire ancestry of the 8 billion people now alive on this planet may have passed through a window narrower than the population of a small town. So, Toba was not the only event of this kind. Earlier bottlenecks appear in mitochondrial DNA, in Y chromosome lineages, and in the strange flatness of genetic diversity across all non-African humans. One controversial 2023 paper in the journal Science argued that around 900,000 years ago, our ancestors may have been reduced to barely 1,000 individuals for over 100,000 years. The species nearly ended more than once. Therefore, the long silence in the archaeological record is not just a story about lost evidence. It is also a story about lost people. When numbers crash that low, the chance of finding any surviving trace of what they built, wore, painted, or believed becomes vanishingly small. Most of prehistory may simply have died with its makers. So, part of the silence is because there were almost no humans alive during certain centuries to leave anything behind. But the consequence of those crashes goes deeper than missing bones. Every time a population fell to a few thousand, something else was happening alongside the deaths. The teaching chains that held human knowledge together were also breaking. To understand what that costs us when we look at the archaeological record, we have to look closely at how a hunter-gatherer society actually passes knowledge from one generation to the next. The way knowledge moves between generations in a hunter-gatherer society is one of the slowest and most patient processes in the human story. A child does not learn from books. She learns from watching, from imitating, from being corrected gently while her hands are still small, and from spending years beside the same adult doing the same thing day after day, until she can do it without thinking. Consider what a full member of a foraging band actually needs to know. Which plants are edible in spring, which in summer, which to leave alone entirely. The ways animals leave tracks in mud, in snow, and in dry dust. The angle at which to strike a piece of flint so the flake comes off cleanly. Star patterns that work as navigation when the moon is new. How to deliver a baby, set a broken arm, and recognize the early warning signs of a winter cold enough to kill. None of this lives in writing. All of it lives only in the heads of the people who already know it. So the chain holds as long as the people hold. A grandmother teaches a granddaughter, who eventually teaches her own granddaughter, and the knowledge passes forward intact across centuries. A skilled hunter trains an apprentice who later trains the next, and a technique that took 2,000 years to refine continues being refined in front of a fire that has been burning in one form or another for the whole of recorded memory. It works because the teachers keep living long enough to teach. But the chain only holds if the teachers live. When a population crashes from 50,000 to 2,000 inside a single bad century, the people who carried the most refined knowledge are not protected. Specialists are rare to begin with. A society of 50,000 might contain a few dozen people who can shape the best stone, a few dozen who can read the stars well enough to predict a season, a handful who know how to set a complicated break, and one or two who carry the oldest songs. When that population gets cut in half, then cut in half again across a single brutal decade, the specialists are almost always among the first to go because their accumulated knowledge does not protect them from hunger. Disease takes anyone above a certain age, and famine kills the elderly preferentially. A volcanic winter shrinks every household, and the elders who eat last by tradition are the first to fail. The grandmother who could deliver a difficult baby dies before she can finish teaching the next midwife. 20 generations of accumulated technique can vanish across one cold decade. But the survivors do not vanish with the knowledge. They keep living. They have children of their own who grow up watching whatever the survivors can still do, which is often a thinner, simpler version of what their grandparents could do. The chain of teaching restarts from whatever fragments survived in the heads of frightened, hungry people focused on the next winter. The same plateau gets climbed again, slowly, from the bottom. Therefore, what looks like stagnation in the stone record may not be stagnation at all. The long stretches where tool styles barely change for tens of thousands of years could be exactly the opposite of what they appear to be. They could be recovery periods after population collapses we have no other way of seeing. When a society of a few 100,000 drops to a few thousand, the people who know how to make the most sophisticated objects often die first. Specialists are rare. A single drought, eruption, or epidemic can wipe out the only people who knew how to build a particular kind of shelter, train a particular kind of animal, or sing a particular set of songs. Therefore, knowledge that took 20 generations to accumulate can vanish in a single bad winter, and the survivors are forced to begin again from whatever they happen to remember as children. So, the pattern that emerges is rebuilt culture, not slow linear progress. Tools stay simple for thousands of years, not because the makers were stupid. They stay simple because every few generations the chain of teaching breaks, and the people who relight the fire have to relearn what their great-great-grandparents already knew. Therefore, the apparent flatness of the Stone Age is partly an illusion produced by repetition. Humans probably reached the same plateaus many times over. The version of history that finally took hold around 12,000 years ago is just the one that managed to keep going long enough to leave farms, cities, and writing behind. Every earlier version lost its grip and slipped under. If you are still here, leave a gentle like. A small like helps this reach others who cannot sleep tonight. Subscribe, and the next slow story will be waiting. So most of the human story is a story of being knocked down and starting over. But there is one starting over moment that sits closer to our own time than any other, and it lines up almost perfectly with the boundary where the silent record begins to speak. To see why it matters, picture the world as it was just before the last great interruption. The Ice Age was finally ending. The conditions for everything that came next were about to be set. Around 15,000 years ago, the world began to warm again. The Ice Age had held the planet in a cold grip for tens of thousands of years, with ice sheets 2 kilometers thick covering most of Canada and northern Europe, and tundra reaching far south of where any tundra sits today. Then, gradually at first, and then more decisively, the ice began to melt. The change was felt everywhere. Forests crept north into ground that had been frozen since before any living person could remember. Animals followed the new vegetation, herds of deer and aurochs and wild horses moving into territory their parents had never seen. Birds returned to coastlines that had been silent under ice for generations. Rivers ran heavier with meltwater and carved new channels through soft glacial debris. The North Atlantic warmed enough that fishing communities could push further along its shores than they had ever pushed before. Humans, who had been clustered in southern refuges through the worst of the cold, spread outwards in every direction, following game, fish, and milder weather into landscapes that were quite literally opening up around them. So, 13,000 years ago, the situation looked promising. Sea levels were rising, but slowly, and glaciers were retreating. But, predictably, each generation could expect a slightly warmer climate than the one before it, and a slightly larger range of places to live in. The story seemed to be moving in one direction, steadily, the way a long winter finally gives way to a long spring that brings more daylight every week and seems certain to keep coming. But the long spring did not keep coming. Around 12,800 years ago, the warming reversed almost without warning, and within the span of a single human generation, the cold that had supposedly been retreating for good came back with a vengeance no one alive at the time could have predicted. Greenland ice cores tell the story in stark numbers. Temperatures in the North Atlantic region dropped by as much as 10 degrees Celsius in less than a century, in some estimates within a few decades. Ice sheets that had been retreating for thousands of years advanced again. Sea levels, which had been rising in slow, steady steps, dropped sharply when so much fresh water locked back into ice, then surged once the cold finally broke. Mammoths, mastodons, ground sloths, giant short-faced bears, and most of the megafauna of North America vanished in the same window. So did dozens of large bird species and entire families of cold-adapted mammals that never returned. But the cause of this catastrophe is still being argued about. The leading explanation is that meltwater from the collapsing North American ice sheets surged into the Atlantic, disrupted the warm currents that kept the Northern Hemisphere temperate, and effectively switched off the climate machine for 1,000 years. A minority view, the Younger Dryas impact hypothesis, proposes that a fragmenting comet airburst over North America triggered the cooling, citing layers of platinum-rich sediment and microscopic spherules at sites across multiple continents. That evidence remains contested. Therefore, the Younger Dryas is not just another wiggle on a climate chart. It was a near reversal of the warming that had been steadily releasing humans from the Ice Age, and it happened almost without warning. Within a human generation, the world that had been opening up slammed shut again. The cooling began around 12,800 years ago and lasted roughly 1,200 years. Greenland ice cores show temperatures in the North Atlantic region dropping by as much as 10 degrees Celsius in under a century. Ice sheets advanced again, sea levels dropped, and then surged once the cold finally broke around 11,600 years ago. Large animals across multiple continents went extinct in waves overlapping precisely with this interval, including mammoths, mastodons, ground sloths, giant short-faced bears, and most of the megafauna of North America. Therefore, the climate that prehistoric humans had been adapting to for thousands of years simply stopped being the climate they were living in. The cause is still being argued over by climate scientists. The leading explanation is that meltwater from the collapsing North American ice sheets flooded the Atlantic, disrupted the ocean circulation, and shut down the warm currents that kept the northern hemisphere temperate. A minority view, the Younger Dryas impact hypothesis, points to a possible cosmic airburst, citing layers of platinum-rich sediment and nanodiamonds at sites across the world. The evidence for that one is contested. Therefore, the catastrophe sits in exactly the wrong place in the timeline. It happened right at the boundary where the human record finally begins to be readable, which means whatever it destroyed went down with almost no chance of being found. So the Younger Dryas destroyed the climate humans had been adapting to, and it did so right at the moment the archaeological record was finally becoming readable. But the strange part is not what disappeared during that cold interval. It is what appeared immediately after it ended. Within a few centuries of the world warming back up, sites began rising from the ground that should not have existed yet by any conventional reading of the timeline. To see what they were, we need to look at what was supposed to come first. The conventional model of how civilization began is calm and gradual. It comes from 150 years of careful excavation, dating, and patient comparison between sites scattered across 4 continents. The story it tells is one most people would recognize from a school textbook. Around 12,000 years ago, in the warming aftermath of the last ice age, certain hunter-gatherer groups in the Near East began to settle down. They built small, round huts. They harvested wild grain and ground it on stone querns. Over a few thousand years, the wild grain was bred into early forms of wheat and barley, and the hunting band slowly became a farming village. Pottery appears around 10,000 years ago, with domesticated animals following shortly after. By 8,000 years ago, places like Catalhuyuk in central Turkey were dense settlements of mud brick houses packed close enough that the roofs became the streets. That is the expected progression, from small settlements to slightly larger ones, from mud brick to stone, from posts to pillars, from villages to towns, and from towns to cities. The pattern is gradual. Monumental architecture is supposed to come thousands of years after the first farms, because monumental architecture needs a surplus, and a surplus needs farms that work. In Mesopotamia, the first temples appeared around 6,000 years ago, well after agriculture had spread across the region. Every archaeologist working in this period for the last century knew where to draw the line between the foragers and the builders. That line sat right at the start of farming. But the line did not hold. Beginning roughly 11,500 years ago, in the warming aftermath of the Younger Dryas, sites of extraordinary technical sophistication started appearing in places where the conventional model said no such thing should yet exist. Göbekli Tepe in southern Turkey is the clearest example. Built around 11,500 years ago, it features carved limestone pillars up to 6 meters tall and weighing as much as 16 tons each. Arranged in circular enclosures and decorated with reliefs of foxes, snakes, vultures, scorpions, and other animals. The construction predates the first known farming villages by centuries and the first known cities by more than 5,000 years. The people who built it left no village behind, no domesticated crops, no pottery, and no agricultural tools. By every conventional measure, they were hunter-gatherers, and hunter-gatherers were not supposed to be capable of this. But Göbekli Tepe is not alone. Karahan Tepe, just 20 miles away, has yielded similar pillars and carved reliefs dating to roughly the same window. Jericho put up its first stone walls around 11,000 years ago in a settlement that still lacked agriculture. Stone monuments at sites across Anatolia, the Levant, and possibly further east cluster inside a narrow window of about 1,000 years immediately after the cold ends. Gunung Padang in Indonesia, controversially dated by a 2023 study to perhaps 25,000 years for its lowest layer before that paper was retracted, hints at the possibility of even earlier construction. Therefore, the timing of these monuments is the part that refuses to be explained by accident. Within roughly 1,000 years of the Younger Dryas ending, sites of staggering technical ambition appeared in regions that had no obvious contact with each other. Göbekli Tepe in southern Turkey was built around 11,500 years ago, more than 5,000 years before the first known cities, and 7,000 years before the pyramids of Giza. Its T-shaped limestone pillars weigh up to 16 tons each and were quarried, transported, and erected by people who left no village behind. Nearby, Karahan Tepe has yielded similar pillars and carved reliefs dating to roughly the same window. Across the region, Jericho put up its first stone walls around 11,000 years ago in a settlement that had no agriculture yet. Gunung Padang in Indonesia, controversially dated by a 2023 study to possibly 25,000 years for its lowest layer, may push the timeline back further still, although that paper has since been retracted. So the conventional model says hunter-gatherers built each of these independently, motivated by ritual needs that emerged around the same time. Therefore, the agricultural revolution must have followed the construction, not preceded it, which reverses what older textbooks taught about how civilization began. Therefore, the question sitting underneath all of these sites is not whether they were built by hunter-gatherers. The question is how much of what was needed to build them. The astronomy, the geometry, the planning, the workforce coordination had been worked out long before the first pillar went into the ground. Something existed before Göbekli Tepe. We just have not found the room it was kept in. So, the monuments themselves are not a mystery. The mystery is what had to exist before them. It would have required centuries of patient observation and the kind of accumulated cultural memory that only stable communities can carry. None of that should have been there yet, according to the standard model of how civilization begins. To see why the question is so uncomfortable, we have to look at what the conventional timeline actually says and where it puts the dividing line between foragers and builders. The standard explanation for how humans went from foragers to builders is one of the great achievements of 20th century archaeology. It was assembled patiently, fact by fact, from sites across the Near East, Europe, Asia, and the Americas. It tells a story that is internally consistent, supported by carbon dating, and broadly accepted by the academic community. The story goes roughly like this. Hunter-gatherer bands began experimenting with wild grain harvest somewhere in the Fertile Crescent around 12,000 years ago. The experiments are casual at first, more like cultivation than agriculture, and they coexist with hunting for centuries. Slowly, over generations, certain grain strains are favored because they hold their seeds long enough to be harvested, and the band starts staying near its grain patches through the year rather than moving on. Sedentary life begins, storage pits appear, and a surplus starts to accumulate around the village floor. With surplus, some people are freed from food production for the first time, and those people start developing specialized skills, including pottery, weaving, metallurgy, accounting, and eventually writing. The whole process takes thousands of years, so the conventional timeline puts complex knowledge well after agriculture, never before it. Astronomy that can predict the solstice to within a single day requires generations of observation and record keeping. The mathematics needed to align a stone structure with a specific celestial event over decades requires the kind of patient teaching that only a settled community with stable, well-fed specialists can support. None of those abilities should appear before farming exists, and none of them should appear in hunter-gatherer bands that have never settled down. But the conventional timeline cannot account for what was actually built. The people who carved Göbekli Tepe had no domesticated grains, no pottery, no permanent village to feed a workforce, and yet they quarried, transported, and erected stone pillars that weighed as much as small fire engines. The astronomy worked into the site is not casual either. Researchers have argued that some of the pillar carvings encode the constellations as they appeared in the sky around the end of the Younger Dryas, with one widely discussed paper proposing that a panel known as the Vulture Stone records the position of stars during a specific cosmic event around 12,900 years ago. Other scholars dispute that reading, but almost no one disputes that the builders were oriented to the heavens with care. The geometric layout of the enclosures, the careful placement of the pillars, and the symbolic system carved into stone all point to people who had spent generations thinking about the sky before they ever picked up a chisel. But centuries of astronomical observation require something the conventional model says hunter-gatherers should not have. They require continuity. A nomadic band moving across territory every few months has no reason to track stellar drift across decades. A small foraging group cannot afford to feed someone whose only job is to watch the night sky. So, either the standard picture of pre-Neolithic life is wrong about how settled and specialized some of those groups already were, or the knowledge that ended up in Göbekli Tepe came from somewhere older that we have not yet found. Therefore, the answer is not the dramatic version that fringe documentaries reach for. Some kind of accumulated cultural complexity existed before the agricultural revolution, and it left traces in stone, because stone was the only medium that could survive what came next. Carving a 16-ton limestone pillar requires more than muscle. You need quarrying knowledge, transport logistics, food surplus to feed the workforce, and someone in charge of geometry. Those things take generations to develop, and generations need stable populations. Therefore, the people who built Göbekli Tepe almost certainly inherited a tradition that had been refining itself for centuries, possibly millennia, before they laid the first stone. So the lost civilization question is really a question of definition. If a civilization requires writing and cities, then know the pre-Younger Dryas world did not have one. If a civilization only requires shared knowledge, coordinated labor, careful astronomical observation, and the ability to organize large building projects across many seasons, then something existed. Therefore, most mainstream archaeologists now accept the soft version of the argument. Complex symbolic systems, large-scale cooperation, and sophisticated cultural behavior predate the dawn of farming by a wider margin than anyone expected even 20 years ago. The harder version, the one involving a globe-spanning advanced society wiped out by cataclysm, has no supporting evidence anyone has been able to publish without retraction. The truth sits between the two, and it is uncomfortable for both sides of the argument. So the gap is real. Something existed inside it that we cannot yet name or date. But before this turns into the kind of speculation that fills bad documentaries, the question worth asking is how we know any of this in the first place. The discipline of archaeology has its own rules for what counts as evidence, and those rules are stricter than most people realize. To understand why the gap stays a gap, instead of collapsing into a story, we need to look at the discipline that has been holding the line all along. Archaeology, the actual discipline, looks almost nothing like the version that appears in films and television. The whips and booby traps and golden idols belong to a different genre. The real work involves slow paperwork and an enormous amount of patience inside a culture of doubt so deep that it shapes the way the whole field thinks. A typical excavation begins with a survey. A site is identified, the surface is gridded, and decisions are made about where to dig. Removal of sediment happens slowly with hand tools and brushes, sometimes 1 millimeter at a time. Every object is photographed in place before it is touched. Soil samples are taken from every layer. Charcoal, when it appears, is bagged separately for radiocarbon dating, while bones are kept apart from stones, and pollen is extracted by laboratories that specialize in identifying which plant species shed it. The whole process is slower and more cautious than most people expect, because the goal is not just to find things, but to find them in a way that can later be defended in front of a room of skeptical colleagues who are professionally trained to be wrong about everything they read. So once a site has been excavated and analyzed, the findings go through the long process of publication. Papers are drafted, sent to peer reviewers, returned with criticism, revised, sent back, and sometimes rejected outright. A new claim about prehistoric behavior, or a new date for a known site, has to survive that gauntlet before it gets accepted into the working consensus. Even then, it can be overturned by the next paper. Doubt is the air the field breathes. But all that care does not eliminate doubt. The further back into prehistory the dating goes, the more crowded the evidence becomes with traps that look like genuine discoveries, until someone notices, decades later, that a natural process produced the same pattern. A stone shaped by frost over a few thousand winters can look almost identical to a stone shaped by deliberate flaking. Bones with what appear to be cut marks may have been chewed by hyenas that died long after the humans who supposedly handled them. Charcoal that seems to date a hearth may have slipped down through a crack from a younger sediment layer above, throwing the entire chronology of a site off by 10,000 years. A line scratched into a cave wall may be an early symbolic mark, or a claw scrape from a bear that wintered in the same cave 500,000 years later. None of these mistakes are obvious. The list of ways evidence can mislead is genuinely longer than the list of ways it can succeed. But there is a deeper problem. The older the layer, the rarer the surviving evidence becomes. A site that yields a single contested tool fragment cannot be cross-checked against 10 neighboring sites, because the neighboring sites no longer exist. A claim that hinges on a single radiocarbon date cannot be triangulated, because triangulation requires more dates than the deep past tends to provide. So the further back the question goes, the more weight rests on individual finds, and the more vulnerable each finding becomes to a single mistake. The gap is not just a hole in the record. It is also a hole in our ability to verify what we think we have found in it. Therefore, the gap is not waiting to be solved. It is not a puzzle with a missing piece sitting somewhere in a museum drawer, waiting for the right person to pull it out and snap everything into place. The gap is structural. It is part of what time does to evidence on a planet with weather, oceans, ice, and tree roots. A stone shaped by frost looks like a tool until you compare it to 100 other stones shaped by frost in the same valley. Charcoal that seems to date a fire layer may have slipped down through a crack from a younger sediment, throwing the whole chronology off by 10,000 years. The bone, with what looks like a cut mark, may have been chewed by a hyena that died long after the human who supposedly used it had been gone for generations. Therefore, the most honest sentence an archaeologist can write is often the one that ends in uncertainty. So the discipline of doubt is what keeps prehistory from collapsing into mythology. Every claim that survives peer review has been pulled apart by a dozen other researchers whose careers depend on finding the flaw. What remains is a thin, careful version of the truth, with most of the color drained out because the color was never recoverable in the first place. Therefore, the gap will keep widening the harder we look. The deeper into prehistory the question goes, the less evidence survives, and the more careful the answers have to be. Most of what was once human is no longer reachable. It has rotted, drowned, burned, or been ground into dust by ice that no longer exists. What remains is not the story. What remains is the part of the story that happened to survive. If this helped you rest, a like passes it on. Subscribe so the next finds you when sleep is hard. Good night.